Now, I will start with discussions on this particular training program that we're going to do, mathematical thinking for financial modeling and MS Excel. Now, why do we need first and foremost mathematical thinking? Let's look at this. Let us say a company has large set of assets. Each asset has different life. It has different salvage value, different purchase price, being bought at different dates. Now, if I were to create a fixed asset schedule, try to forecast what will be my fixed asset as of 2022, balance sheet numbers. Because everything is different, what you would notice is that when you don't think about crunching the problem into small pieces, we make blocks and blocks of tables. So for each asset, because each asset is bought at different dates, has different depreciation rate. So I will have to create one for one block of asset, another one block for another asset. And I'm going to keep creating this. And there's a limit and there's a pro to this kind of work that I can do. And it comes with a lot of risk. What is the risk? The risk is right now I am going to, if I have 50 assets, I'm to create 50 separate schedules. And let me tell you, some of you already probably have experience in modeling and you probably relate to this. This is how most of us build financial models, right? Most of our calculations would be, we take these 50, if you have 50 assets, create separate 50 schedules. And then you add all of them together and get the total. Now, A, this takes a lot of time. B, time is still okay. The bigger problem for us is tomorrow, if I add one more asset, I will have to come here. I'll have to add one more table and I will have to make sure that all the data gets rolls into my totals, because if I purchase an asset, if there are 50 assets, then my total purchase for the year should include all 50. And when I buy a 51st asset, I will also have to add it here. Purchase should be added, depreciation should be added, closing balance should be added. You have to take care of all these things. And this makes our work pretty complicated. And that is where mistakes happen. Mistakes happen because later on, a lot of time when people work on Excel, first time when they work on Excel, your file looks absolutely correct. Where the mistakes happens is later on when more and more data falls in, people forget to add it because, well, it's been a while since I built the model. So I don't know where all this should go. But when you apply mathematical thinking, when you think about shrinking the problem, if you look at it, that same data, what you see, so where you see total asset value is 41, 715, 2021, I have exactly that same number here, but this problem has been crunched. In fact, that data is wrong because that data was created before I added some lines. When I added some lines, that didn't fall into it. But here, it automatically factors in every single data that I add, and all the calculations have flown into a single schedule. And this we could do because we could mathematically crunch the problem into smaller pieces, right? So that is the purpose of mathematical thinking. So what we're going to do is, let's go through these files. And so let's just think about this. Now, let's look at these problems. Some of these problems, when you think using if function or something, it would be pretty straightforward to you. But let's try to understand, how else can we do it? That is the idea. So what we've been given is we are dealing with the problem where we are saying an analyst expects value of a commodity to increase and decrease by 5% on alternative days. For example, if return on day 1 is plus 5%, the return on day 2 should be minus 5%, right? And day 3 is going to be plus 5 and so on. So we want it for 20 days. Now, how would we do this? So basically what I want is, if I look at first problem, as I told you, if you have Office 365 or Zoho Office or Office Online, life would be better because we could use the sequence function. So I'm going to have sequence 20, which is going to give me a sequence of 1 to 20, right? This is my day. Now, normally, how would you do it? Normally, most of us would be thinking about if function, right? Minus 5%. I would put it here. And then you can go and say, or you could even simply put minus of minus, right? This is an iterative approach. Minus 5 and then plus 5, minus 5, plus 5. You can think of it. One problem with this approach is that this data, every data depends on what is the data in the previous data, right? Now, if you're working Excel the old way, there is one small risk here. The risk is by chance, if any of the data gets deleted, if one data gets deleted or removed, your subsequent series goes for a toss because everything was linked to its previous value, right? That is one problem. And when you're working with dynamic array, this mathematical thinking becomes even more important in dynamical array concept, because in dynamic array, as you could see here, I'm going to just put one formula. I'm going to put one formula that is automatically going to change the signs, right? I just have to put one formula. So I can, I can put something like equals. If it was all supposed to be 5%, I can put a formula saying that 5% into, let us say, I could say sign function. A sign function basically tells you if it's a positive number, the sign function will give you answer as 1, right? That's what the sign function does. So if I use sign function, it will give me 1, 1, 1 because these are all positive numbers, nothing else, right? So I want this 5% to come 20 times. I'm going to do this. But what we want is 5% and minus 5% and then 5% with one single formula, which should not be iterative. Is there a way you can think about it? How do we do that? If I take minus 1 raised to the power this number, right? Minus 1 raised to the power 1 is going to be minus 1 times 5%, right? And minus 1 raised to the power 2 is going to be plus 1. Plus 1 into 5 is plus 5. And minus 1, you could copy paste it. If I was working with dynamic array, I would simply put it this way: 5% times minus 1 raised to the power. I'm not sure how many of you are aware of dynamic arrays and how to work with it. So I use a sequence function to generate sequence of 20. If you're not using dynamic array, it's okay. You can just type 1 to 20, right? And then you could copy and paste the formula like I did. But what I'm going to do is I'm going to say equals 5% multiplied by minus 1. See that 1 to 20 was all obtained using one formula. So they form part of one array. So if I'm going to refer to say that, C23, the array starting at C23, if you're using Office 365, you could then add a hash sign. That indicates that, I'm taking 1 to the power 1. Next cell should be minus 1 to the power 2. Then third one should be minus 1 to the power 3 and so on. So you press enter. Of course, formatting we need to take care. And that closes the data for us, right? We could achieve this. And as I said, what is the advantage here? One, in dynamic array, I had to use it, right? I could not put previous negative of previous cell. That was not an option. And another thing is here, if any value in between got deleted, that value, obviously, if you've deleted it, that would be wrong. But rest of that doesn't suffer. My rest of my values are absolutely fine. Now let's go to 1B. And I think 1B, I've already got part of the answer. Let's look at the 1B here. If my starting price is 250, right? And I want to know what would be the price on day 99 and day 20. Let's for a moment assume that the price would be plus 5 and starting would be minus 5, right? Let's assume day 1 will be minus 5, day 2 will be plus 5, right? Either ways. Our idea is to do it without generating the series, because most of the time what you would see people would do is they would do it again iteratively. So 250 times 1 plus 5 minus 5, I get an answer. Then 237 times 1 plus. So I first find every day's value and I go to day 100. The problem is, a lot of us are okay doing it. But the problem is when you do this for 100 days, you need 100 rows of data, right? Which is not a great idea. So what else do we do? Any thoughts here? I already got an answer actually. Let's talk in mathematical terms. Our final answer, I've got one more. So how are we going to do it? So if you think of it, since it is alternative, on odd days, if my total duration is even, if I'm talking about 100 days, how many of positive returns would have been there and how many negative returns would have been there? 50, isn't it? If I'm talking about 100, I would have had 50 each. 50 positive and 50 negative. If we are talking about 99 observations, my first observation is negative. So how many positives and how many negatives would have been there? 49 positives, because my first observation is negative, which means 99th would also be negative, and 50 positives, right? So now how do we get this? So if I have to mathematically do it, I'm going to do it as 100. Sorry, 250 is my first value. Keep in mind, for 50 times, I would have multiplied it by 1 plus 5%. So that becomes 250 into 1 plus 5% to the power 50. And another, in case of 99, this would be 49. In case of 100, this would be 50. And there would be another 50 occasions where I would have done 1 minus 5% raised to the power 50, right? So one thing I can do is, I can directly do this part. Let me just clear the screen. So I could do 250 times 1 plus 50%, sorry, 1 plus 5%, because you on 50 days, you would have done previous day value into 1 plus 5% raised to the power 50. And another 50 days, you would have done into 1 plus 5% raised to the power 50. Sorry, 1 minus, my bad. So that gives us 220, right? That would have been our answer. And if it was 49, then we would have done the same thing. Only thing is, for positives, I would have attached 49. Right? So that's fantastic. Now what we're going to do is we're going to bring in a little bit of Excel into it. So when I say mathematical thinking, I'm not saying don't use Excel. Sequence function is Excel. We are going to use Excel. Now let us say, how do I automatically make Excel figure out how many positives and how many negatives? Right? So if I have 100, then I need to get, I'll put negative and positive because the first number is negative, second number is positive. So if it's 100, I want 50, 50. If it is 99, then I would want 50, 49. If it is 97, then I would want 48, 47. Sorry, 49, 48. Now, how do we make Excel do this for us? If I round down, because the number of positives is going to be less here, because I know the first value is negative. So for positives, if I divide 97 by 2, right? If the number is even, then both the numbers would be same, right? If we are talking about 100, then both of them would be same. But when I talk about 99, when I divide it by 2, because it happens alternatively, the one that starts first will have higher number, and the one that starts later will have 14 lesser number. So what we could do, you could just round it down, round down this division to 0 decimal points. And the first one, you could round it up to 1 decimal point. Right? So if it's 100, you're going to have 50, 50. If it is 93, you're going to have 47, 46, 92. And then here we could have our formula equals 250, which is my first value, times. I'm not following certain Excel best practice. Normally in Excel, we would say don't type input directly into the cell. I'm not following it very religiously here because the focus is more on the mathematics. So 250 times 1 minus 5% to the power 47 times 1 plus 5% to the power 47. This thinking process, what is the advantage? You can directly go to your final answer. Whether it is 100 days or 1000 days, I don't have to bother. I know what the answer is going to be, right? You can even rework it. If by using a bit of a logarithm, if somebody says by when this would go to, let's say from 250, in how many days would it go to 50? We could rework, because now I'm explaining this in the mathematical equation. I can find this out, right? I can find out what is the n for which this condition is satisfied, right? So this is something that we can do in terms of, I mean, this is one of the examples I just wanted to give you. And to just give you a thought about its practical implementation, it was not exactly the same, but there was one of our client who had a very similar situation. whose idea was that, if my market behaves in a particular pattern, in how many years my money would, let's say, double. So it's not flat 12% CAGR. We are talking about returns increasing at a particular rate and then decreasing and then increasing. If market goes in cycle, how long will it take the money to double? Eventually, their original file was, it did the entire calculation for, let's say, next 1,000 years, just to be on the safer side. And then you using a match function, you figure out, when does the money give? If I'm investing 1 lakh, when does 2 lakh come in this entire segment? But you need not have done that. If you crunch it into an equation, we can figure out what is that n for which this would be satisfied. So now let's go to question number 2 here. Let's look at this one. What we have here, I'm going to use a little bit of Excel. In the above series, let's say the analyst thinks that the price, when it increases, will increase by 5%. When it falls, it will fall only by 3%. Right? So when it increases, it's going to increase by 5, but when it falls, it's going to fall only by 3. How do we handle this problem? A bit of Excel will be required here. So what can we do here? So I want to get a returns where almost same pattern, negative followed by positive, followed by negative, followed by positive. But positives have to be 5%, negatives have to be -3. So firstly, I can do the same thing what we did earlier to get the plus and minus. That's going to be -1 to the power the range. So what I can do is step one way to look at it is I can say, day 1 is going to be negative. That is how we are starting, right? So day 1 is going to be negative. So I will start with 3% multiplied by, see, all the odd days. If day 1 is odd, negative, that means all the odd days are going to be negative. So I'm going to put a function here saying the 3% times is odd. So which means for odd numbers alone, for some of you who may not know Boolean functions, just to give you an idea, what is going to happen is if I give is odd, that means it's going to tell me whether the number is an odd number or not. If it's odd number, it's going to give me answer as true. For even numbers, it's going to give me answer as false. Okay. So when you're working with dynamic arrays, some functions don't work very well with the array. So is odd did not work very well. In that case, all you have to do is add a plus sign before that reference. Then it works. So you notice that all the odd numbers come as true and all the even numbers, it shows false. And in Excel, true acts as 1, false acts as 0. So if I'm going to put 3% times true, so 3% times 1 will be 3, 3% times false will be 0 because false is 0. You notice that we have it this way. Now, what can we do in terms of getting 5% on the even days plus 5? So I want it to be plus and minus, we've got it, -1 plus 1. It has to be 3% on odd days and 5% on even days. How do we do that? Let's do one thing. I can put it this way. If you're comfortable with if function, let's do if function. It's okay. I'll break it into lines, basically. Let me break it into lines. The absolute value should be if this cell, let me for a moment not use dynamic array. If this cell is an odd number, then give me 3%, else give me 5%. Sorry, if it is odd number, comma 3, my bad. And then I could multiply it. 3% times -1, which is -3, right? Now, of course, in this case, if function itself would have been sufficient for us. But as I said, where it would have been a little tricky for us is when you're working with dynamic array. So you could use the -1 square and we could have used that technique like what we got earlier so that my data doesn't depend on its past data. Okay. Now, let's look at the second one. In this case, again, in 99 days, what would have happened? How will you figure out? So what I can do, almost like what we did earlier, negatives and positive take round up. Only thing is, here for the negative returns, I'm going to use 3%. And for positive returns, I'm going to use 5%. So what is going to be my price, right? We could have directly gone for it. So 100 or 99. So I don't have to generate a series. So a lot of them people would think of generating the entire series and then using a match function or a lookup function to figure out what is the price on the 99th day or 100th day, or we could directly go into this, right? Now I'm going to come to question number 3. Let's just read it. What have we been told? We've been told that the price of a commodity, almost on the same lines, we are trying to simulate it in such a way that it'll increase by 2% for 2 days, and third day it'll fall by 3%. So it's not alternate days. 2% on day 1, followed by 2% on day 2, following by 3, then falling by 3% on day 3. Then again, day 4, day 5, it'll increase by 2 and 2. Day 6, it'll fall by 3. 7, 8 increase by 2% each. 9 fall by 3. If you have to generate this series, because it is not just odd and even numbers, right? There are odd days where 1 and 2 are odd days, where, 1 is an odd day, 2 is an even day. On both the days, price is increasing. 3 is odd number, price is falling. But 6 is also an even number, that day price is falling. So how do we handle this one? So 1, 4, 7, 10, it should increase. 2, 5, 8, 10, it should increase. 3, 6, 9, 12, it should decrease. So in other words, it should increase on all days. How else do we rephrase the problem? It should increase on all days except 3, 6, 9, 12, 15. And what is common between 3, 6, 9, 12, 15? They're all multiples of 3. Now, how do you find out whether my data is a multiple of 3? I'm going to take us back to school, 3rd standard, and then we'll come to it. There are 2 ways you can find them. One way you can find them is, see, if a data is multiple of 3, in school days, we would have got this quotient and divider. So quotient would be, if I divide 1 by 3, 1 doesn't go in 3 or 3 doesn't go in 1. So that means it'll give me a quotient of 0, right? Because 3 doesn't go in 1 at all. And reminder, the remainder can be obtained in Excel using mod function. Mod of this number divided by 3. Why 3? Why are we taking 3 here? Because each cycle is of 3 days, right? Day 1, day 2, day 3. Then day 1, day 2, day 3. So if you notice one thing, that the remainder, when you divide the number by 3, on all the multiples, 3, 6, 9, 12, 15, on all those cases, my remainder is going to be 0. Right? That is what is happening here. So now with this understanding, how do we apply this? So which means 2% should happen on all days, on positive on day 1, day 2, minus 3% on every 3rd day. So can we get this for 20 days if I have to get it? What I can do? See, we know that if it's multiple of 3, the modulus will be 0, right? So I can just put this thing that if the modulus of the number, comma 3, because each cycle is for 3 days, if this modulus equals 0, then get me minus 3%, else get me 2%. And we can see that we could generate this return, right? We are using if function, but I said, I probably would not even use the if function here, but it's okay. We can, to start with, let's use if function. It's okay, but we could easily generate this pattern 2, 2, minus 3, 2, 2, minus 3. If the start price is 99 and we are talking about number of days could be 99, it could be 100, it could be 101, whatever be the days, then how do you get the returns in this particular case? Each day return I know, but I want the final price. So here I can have negative. So if it is, I'll round it. If I do a round down of 100 by 3, so that will tell me that at 33 negatives, balance is going to be positive. 100 minus 33. So I can do it as 250 times 1 plus 2% raised to the power 67 times 1 minus 3% raised to the power 33. 344. Let's go to problem 2. Let's look at this one. And the idea was this, that, we are getting into a contract, and the contract allows me to increase the price by 5% every 3 years. So it's not a year over year growth. It is not every year growth. You are increasing price by 5% every 3 years. So if I needed to get the price over 20 years, now how will we do it? Now, in general, some of you might know the compounded interest principle. So if there was a 5% growth on a constant basis, because on day one, what would happen is, in year one, I'll have 100. If it was growing at 5%, it'll grow at 5%. That's at the end of year one, right? At the end of year two, what is going to happen is it'll grow again at 1 plus 5%. At the end of year three, it'll again grow at 1 plus 5%. So for my first year, I can write it as 100 into 1 plus 5. Second year, because we're going to take it twice, I would write it as 100 into 1 plus 5% square. And third year would be 100 into 1 plus 5% to the power cube. So in general, we can say a value at the end of n number of years. So you see 3 years means it's raised to the power 3. 2 years is raised to the power 2. So this is a compound interest formula we all would have studied. So if you want the value 5 years from now or 10 years from now, it is going to be value at the time of t plus n. Sorry, it will be today's value into 1 plus the rate of growth power number of years. This is something we all would have learned. But what we have here is a slightly different problem, because the growth is not every year. The growth is every 3 years. So let's talk about this one. How do we do it? So 5% jump. So if I were to manually do it, if I started 100, first 3 years it's going to be 100. And fourth year is going to be 100 times 1 plus 5%. Right? But this is again an iterative process. If I were to do it iteratively, I can do it this way, right? But we don't want to do it. And especially in some of the cases, you don't have the option. You don't have the option, because I've had situations where, for example, somebody would start it in the year 2. So for them, the 100 would be, I have, let's say, 5 different clients with whom I entered into a contract. For somebody, I entered into the contract on year 1. For them, the series is going to be 100, 100, 100, and then 105. Right? For somebody else, I entered the contract in year 2. So for them, the series would be different. And I cannot manually do it for each of the series. So is there a way I could come up with a formula so that, I could automatically get this? Again, not keeping it iterative. Because if you keep it iterative, then your one value depends on the previous value, which is a little problematic for us, especially when you think of scaling it. So think of this way, right? So I am going to take the same equation, but what I'm going to do is, instead of the n being referred in years, I'm going to refer to the n in blocks. So this is my base block, so that is 0. 4, 5, 6 is my block 1. 7, 8, 9 is my block 2. Because if I have my block this way, then I can write my simple formula like this. I can say 100 times 1 plus 5% raised to the power block. 100, 100, 100, 105, 105, 105. So if the block is of 3 years, why we are putting 3 times? Because the size of the block is 3 years. Now the question is, how do I get this 0, 0, 0 and 1, 1, 1 and 2, 2, 2? We could use the quotient function, right? But there is a twist required, because let's see what happens. If I use quotient function, do I get 0, 0, 0? So quotient of 1 upon 3 will be 0. Fine. Quotient of 2 upon 3 is 0. Quotient of 3 upon 3 is 1. So if you look at it, the numbers are, quotient is going a little ahead of us. We wanted 0, 0, 0, then 1, 1, 1. But what is happening to us is 0, 0, then 1, 1, 1. Not exactly matching to our requirement here, right? What is happening is, not x plus 1. So what is happening is, my 1 should start here. In fourth item should be 1. But here the 1 is coming a little early. The quotient function gets it a little early. Same with 2. 2 gets it a little early. So it gets not little early, it gets early by exactly 1 item, right? So what I need is not quotient of this number. I need the quotient of previous number. So what we can do here, I could say equals quotient of the year minus 1, comma 3. And we could get this. Of course, see, I'm doing it for, from a workshop perspective, so I'm breaking it. In real life, I wouldn't break it. In real life, I would not break it into two separate blocks, two separate columns. I would just have a formula like this: 100 times 1 plus 5% raised to the power quotient of year minus 1 by 3. One single cell would be enough. Since we are doing it in a classroom perspective, I am just breaking it into pieces, right? Because again, why I specifically brought in this problem was that in one of the cases that I saw, people had a big formula. They had a formula with a range of if function running in. If this value is greater than, let us say, less than or equal to 3, then 100. Otherwise, check if this value is less than or equal to 6, then 100 times 1 plus 5%. Then check if it's less than 9, check if it's less than 12. It went on for that. So these people went up to 12 levels of nesting and said, I will do that. Not required. If you think mathematically, that's all. But just this quotient and mod, with that, we will see what more we can do. And there we will try and figure out, what kind of additional data we can bring in. Now let's come to this one here. This is purely for academic purpose. But the second one is not academic purpose. First one is pure academic purpose. Let's think of this way, that let's say I'm going to look at unusual pricing where the price payment is going to increase in multiple of 15 for each of the quarters. So first month I'm going to get 15, second month I'm going to get 30, third month I'm going to get 45, fourth month again 15, 30, 45, 15, 30, 45. This is the pattern I want to repeat, right? Practically, you don't come across, I have not come across at least this situation, but let's pretend that we have a very fancy contract which has this funny things, 15, 30, and 45. How will we generate this pattern? So very simply, all you have to think of is, how do I come up with first month of a quarter? This is the first month of a quarter. This is the second month of the quarter. How do you come up with that? So let's insert a row in between probably, right? Month of the quarter. Because if I can get this 1, 2, 3, 1, 2, 3, right? Then life is simple, right? You can just put 15 times 1. 15 times 1, 15 times 2. Life would be fine. So only thing we have to do is come up with this 1, 2, 3, 1, 2, 3. How do we do it? Again, let's go to the beauty of the mod function. This is the beauty of the mod function. One of the beautiful thing about mod function is, or reminder as a concept, most of us don't think of using reminder. Reminders always run in cycles, right? So if I was to divide it by 5, let me do it in 5. You will notice that reminders will always run in cycles. 1, 2, 3, 4, 0. They always go in cycles. So quotient runs in blocks. So if you want same value to get repeated multiple times, so if you want things to go in blocks, you could use quotient. And if you want something to go in cycles, you could think of using reminder. So can we think of how do we get this 1, 2, 3? Now that I've told you that if you want something to keep repeated, a series to keep coming again and again, you could use a mod function. What can we do here? Mod of this, comma 3. One problem is I wanted to run as 1, 2, 3. This is running as 1, 2, 0. Because 3 by 3 leaves 0 reminder. You could use a if function saying that if the mod is equal to 0, then it's 3, otherwise 1. But there's a simpler solution. See, if you look at this, 0, 1, 2, right? What I want, 1, 2, 3. What the mod function is giving me is 1, 2, 0, and I want 1, 2, 3. But if let's look at these two. Can you make some pattern out of this, of the area that I've shaded here or highlighted here? So if you look at it, what you can do is the number I want is 1 plus the mod of the previous number. Do we see it here? So 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3. So the number I want is 1 plus mod of the previous number. So one thing I can do is I can do D11 minus 1. So that means I'm taking previous number. How do you say previous number? We don't want to do one thing. A lot of time people would say previous number is previous cell. Let's not do that. It has to be depend on current value. So how do I say previous number? It has to be current value minus 1 divided by 3. So that means I'm going to get the mod of the previous number. Let me add 1 to it. So if you wanted to go as 120, 120, then you can use mod function as it is. But because mod function is going to come up with a 0 for the multiples, right? If the number is a multiple of 3, it will give you answer as 0. It won't give you answer as 3. So what we can do is, if I want that to, for all the multiples, I want the full number, you could do this technique. Mod of D11 minus 1, comma 3 plus 1. Now we can see that the value goes as 1, 2, 3, 1, 2, 3, 1, 2, 3. Any questions? Any thoughts? Now let's go to problem number 2, because this is very practical. We face such situations when you're building budgets for companies or anything. One of the things that could happen is, let's say I have a loan that I've taken and I have to repay 240,000 on February, May, August, and November. So it's a quarterly installment, not monthly. So it has to hit me exactly in February, May, August, November, right? Only on these months it should hit me. When you're building models, iteratively or manually doing something is one thing. So I could type 000 and 240 and then 00 240. I could type it manually. But when you're building automations, this is not what we want to do. I want one formula that can automatically pick this up, right? So what formula can we use here so that the payment of 240 hits me exactly in these months, February, May, August, and November. So they all have a gap of 3 months, but how do you tell Excel that they have gap of 3 months, or any programming language for that matter? What else is common? So one of the thing is February is month 2, correct? So we're talking about month 2, month 5, month 8, and month 11. And all the 4, 2, 5, 8, 11, they have gap of 3 months, but what else is common between them? They're all second month of a quarter. So how do we make Excel figure out that is the second month? A quarter has 3 months. If you divide all these value by 3, they will leave you 2 as reminder. And why am I dividing it by 3? Because it's a quarterly payment. So I'm going to check if mod of the month number, I've already got the month number for all of us in quarter row 19 or 20. Check for the mod. If the mod is equal to 2, then 240 payment. Otherwise, no payment, because my payments can hit me exactly on these months. If it was half yearly, how this formula would have changed? Let's say it was supposed to be only on February and August. What would have been the difference in our formula? If it is half yearly, I'll divide it by 6, because what is common between February and August is they both are second month of the half years, right? 2 and 8, they are both second month of the half years. So let's divide it by 6. I can check whether it is 2 and then I can use it. Now let's go to the third one. Now we have this data with us, 60, 70, 80, 90. This right now is manually punched in, right? I want the formula to generate this. How do we do this? If I were to allow you to use the if function, you probably can still do it. I mean, I can tell somebody who would probably put a formula like this, saying that if I want to know whether this is the increasing series or a decreasing series. So I'm going to check if this number is equal to 90, and you can see here, the formula is going to get pretty crazy. I'm going to say, check if this number is 90, and then check if this number is greater than previous number. If this number is 90 and greater than previous number, that means we have last month I reached the peak. So this month it will be 90, right? This is how most of the time our thinking process goes. What else are we going to do? If this number is 90 and if G31 is same as last number, then that means I am in a decreasing series. So take previous number and reduce it. Otherwise, I'm going to say, okay, if it is not 90, then what happens? Then I need to know whether it is an increasing series or decreasing series. So I am going to check whether this number is greater than previous number, because if it is greater than previous number, then I'm in an increasing series. Then I will say take this number and add 10 to it. If it is decreasing, then again, question is the moment it hits the bottom. The moment it hits the bottom, I'm going to check one more thing. Check if this number is less than previous number, but this number is 60, that means I have hit the bottom because we are in a decreasing series. So keep it 60. On the other hand, if this number is 60, it's already sounding crazy, right? If this number is 60 and this number is same as previous number, that means we now have to start increasing. Then it has to be this number plus 10. And this is using if S function, which is only in Office 365. If you were using if function, it would have sounded even more crazy, right? What happened? Maybe I still messed up something. Oh, this condition is not even given. I didn't even give this condition. Okay. Right. It's going crazy. What else do we do? That's why we're going to think of mathematically, how do we approach this? Right. We'll not want to use if function at all. Let's see if we can break it into a series and patterns. See, my base number is 60, right? So let me do one thing. I'll keep the base as 60. Now, if I look at the delta of my number versus 60, let's see what we notice here. I see the delta is 0, 10, 20, 30, right? And then again 30, it's 20, 10, 0. It's really not solving my problem. Let's do one thing. I'll do, because this is an increasing block, right? So I'll keep the base of increasing block as 60. Decreasing block, let me make it 90, because decreasing block starts from 90 and it's false, right? And then increasing block starts at 60. So all the increasing blocks are going to be 60. Decreasing blocks, I'm putting the base as 90, because decreasing, you're falling from the 90. Again, you're increasing from the 60. If I notice in here, something is happening. 0, 10, 20, 30. Then 0, minus 10, minus 20, minus 30. 0, 10, 20, 30. Right? So this one is 16. So I have to think of, how do I generate the 60 and 90 and 60? That is one part of the problem. Second part of the problem is here, the numbers are repeating, but the signs are changing. 0, 10, 20, 30, 0, minus 10, minus 20, 30. So 0, 10, 20, 30 is repeating, but the signs are changing. How do I generate 0, 10, 20, 30 to come multiple times? Is there any way I can generate this to come multiple times? We can use reminders. Reminder of what and what? See, we are talking about period, right? So what you can do is, since the increment number is 10, right? Let me put it here. So base is 60. Increment is by 10. These numbers won't be available to us. This is just for illustration to show what answer we want, right? That won't be available to us. So which means it has to increase by 10 every quarter, right? So what I can do here, I'm going to put equals 10 times. If I put mod of this 1, 4. Why am I taking 4? Because cycle is 4 months, right? Sorry, D35, let me freeze it. Yeah. This goes as 10, 20, 30, 0, 10, 20, 30, 0. What we want is 0, 10, 20, 30. What do we do? I want 0 to come here, 10 to come next, 20 to come next. So mod of D30 minus 1, right? So this part gives me 0, 10, 20, 30, which I wanted to achieve. That's fine, right? So this is basically my delta, absolute of delta. The absolute of delta is 0, 10, 20, 30, 0, 10, 20, 30. But what I want is not that the signs should change. So what we can do here, let's get the blocks, because we know one thing that in the first problem we did that, if you wanted to get alternative -5 and +5, what you can do is you could use -1 to the power, right? And in problem 2, we also did one thing that you could use a quotient function to get the blocks. So here I'm not talking about block of 1 quarter, 2 quarter. Every 4 quarter is one block for me, right? Every 4 quarter is one block. So let's get the block numbers here. How do we get the block number? So block is going to be quotient of this comma 4. But if you remember, we did the same problem. For 4, it comes as 1. So what I could do is I can say, D30 minus 1. 0 means base block. So when I use a quotient function, 0 comes 4 times, 1 comes 4 times, 2 comes 4 times. So what we can do is now to change the sign, delta with sign, I can take this delta multiplied by -1 to the power block. And we've got this. We are not yet done because these cells are all formula driven. Fine. These two are inputs, of course. So let that input be there as it is. But the 60 and 90, what do we do? Because it should be 60 up. We said, the increasing block will be 60, the base, and for the decreasing block, it's going to be 90. Keep in mind all the time where 60 is coming. Let's look at the block numbers. What is common about the block numbers where 60 is coming? And what is common about where block numbers are 90? It is odd and even numbers, right? So one thing I can do is, if need be, I can do it this way. That's saying that, if the simplest thing to do is, if it is even, then give me 60, otherwise give me 90. Sorry, the block, not the quarter, the block. So now we have got this. So if I add this to base and delta, if I add the two, I would get the price I want. Right. This is exactly what we wanted. 60, 70, 80, 90, 90, 80, 70, 60. It can keep going on in cycles. Now, one thing is, just to let you know, you can even think of this 90 slightly differently. If you think of it, can I also look at it as, the 60 is base, 90 is basically 60. That's why I have left a line in between. So what I could do is simply this. 60 is my base. That will always be the case. And in the peak, there will be a 30 added. So 0, 0, 0, 0, 30, 30, 30, 0, 0, 0, 0. What is the 30? That's a max delta. So I can look at it as, peak is 90, which means the max delta you will ever find is peak minus base is 30. And that means one of the thing I can do is, any idea what we can do here? Just to get the 30 only for these odd blocks?
Simple. Wherever there is negative symbol, whenever your mod is coming as an odd number is odd, you go ahead and add 30 to the base. That's it, simple. When the quotient is even, in that time you'll not add it, assuming you start at 60. So when the quotient is a positive, is an odd number, is odd, you multiply it with the sign of -1, and then you add 30 to it.
Exactly. So we can do that, and we've got this, right? Again, see, we are learning it. This framework, probably not all of us think on these lines. So that is why I'm breaking this into so many blocks, block, and then absolute, then delta with sign, then. So this calculation has been broken into 6 separate rows because we're doing it for the first time for a lot of us. That is why we have done this, but you don't need to do it necessarily in so many lines. We could have done it in one single line. But yeah, if somebody wants to understand it and we want to break it, we can as well break it in these lines. Right. So as you can see here, a lot of things can be done provided we try to break this into a pattern and series. And that is where the mathematical thinking comes, rather than thinking about, okay, I'll jump into if function and I'll see, put a logic. If we can think of, what kind of patterns and logic exist here, from there, it becomes easy for us to go and pick up the answer. I'll go to P4 a little later because, we've done a lot of mod and quotient and roundup based answer. For a change, I'll go to P5. P5 is a very simple thing. If any of you have worked on infra contracts or something like this, you might have come across something on these lines. So what I have is, let us say, just think of this way. I'm going to sign up a contract for a toll road, and I expect 50,000 vehicles to travel in this road in a year, right? And I'm going to charge 20 rupees or dollars, whatever, per vehicle. Now, I've been told that the traffic volume will increase by 2,000 units per year, and toll charges will increase by 5% per year. So which means my traffic volume would go something like this: 50,000, 52,000, 54, and so on. And my toll charges will go as 20, 20, and 1 plus 5%. And then 21 times 1 plus 5%, and so on. So my revenue is going to be, first year would be 50,000 times 2, second year 2,000 times 21, third year 54 into 22.05, right? So sometimes, I've signed up a solar power contract or signed up a toll road contract, which has a life expectancy after which it's on a boot basis, so I have to surrender it. Could happen. So let us see if this is the data, right? Of course, this is oversimplification of a real life models. Real life models are more complicated. Things don't work on a pattern like this. But let's say, at least for a longer term, I think this pattern will continue. After the first 5 years will be erratic. 6th year till 15th year, this pattern will continue. So now what I want to do is I want to find out what is the present value. Firstly, let's talk about simple summation. I want to do this for next 10 years and I want to sum it up. Now, if I allow you to do it, break it by cells, we will do it, right? All of us would do it. So do it for 10 years, 52, keep adding by 2000. 4th year, 5th year, 6th year, 7th year, 8th year, 9th year, 10th year. So we've got this. And we've got the answer. You sum it up, right? Let me get everything in millions probably, so that the number looks smaller. So we can sum it up. But the question is, can we do it in single cell? And firstly, why should I do it in one single cell? That's another thing. Because one thing I always tell is that, in Excel, you have every sheet has 2 dimensions, rows and columns. The moment you've taken the 2 dimensions, most of us don't think that way. We are okay putting another box somewhere here and another box here. But files like these become pretty messy to handle. So one single row, I would say, should have, a column should be all identical, in the sense it should all represent same thing. Same way a row should represent same thing. So multiple boxes, not very ideal. So if my calculation already occupies both the dimensions, then that's a lot of space. Now, third dimension, if I want to add one, where will I go for it? So if I can do it all in one single cell, this entire calculation, life would be good. We will need Excel for it. We will need Excel for it to help us out. And you can also do it in the older version of Excel, by the way. I'll also show you how to do that. But question is, how do we, if I have to do it, what do you see about this series? Do you see any pattern emerging here? Because if you can find a pattern, then we can think about, how I can make Excel to do this. Can you find any pattern, any something?
In column C and GP in column B.
Exactly, right? So this one is going on arithmetic progression. It's increasing by 2000 every month, right? So if you remember, arithmetic progression is of the form A plus n minus 1 into D. A means first value. What will be the first value? So first value is 50,000. N, of course, we have it here. And what will be D? D is the difference between each value. D means what is the difference between first value and second value? 2000. So one of the things is, rather than doing it iteratively, if I wanted to get what would be the 10th value, I could have simply done it as 50,000 plus 10 minus 1 up multiplied by 2000. That would have directly given this, which avoids the iterative process. I don't have to get the previous value to know the current value. I could have directly jumped to this. This one is GP. What is the form of a geometric progression? Into r to the power n minus 1. Because first value is A. R is the ratio between first value and second value. So what is the ratio between first value and second and first? I'm sorry, second and first, or third and second? So what would be the ratio? This by this, right? 1.05. 1 plus the growth rate, right? So A is going to be 20. D doesn't apply here. The ratio is 1 plus 5%. So if you think of it, we could have generated this entire series without making it iterative. Eventually, I'm not even going to keep it in these cells. I will also show you how to not keep it in any cells and directly come to the answer. So here I could have done as A is 20 into 1 plus 5% raised to the power n minus 1. And that means we are directly jumping to the last value, right? Now, in between, if you delete any value, my subsequent values don't change, right? So this is not an iterative process. In the earlier approach, when I took previous value into 1 plus y into 1 plus y, it was iterative. Here we are eliminating that iteration. Now let's think about how do we do it in a single cell, right? So one thing I know is I can get my quantity as 50,000 plus n minus 1. N is 10, right? I want 10 values to come together. Now, if you're using Office 365, this can be easily obtained as sequence of 10, because sequence function is what I used earlier, if you remember, which gave me 1 to 10. Right? Sequence of 10 minus 1 into 2000. This formula would have given me this, 50,000. In the older Excel, if you're doing, you don't have sequence function, this can be done a little painful. You will have to put as 50,000 plus, if you want to generate 1 to 10 as a series in the older version, we use a technique of using row function, because what a row function will do is if I say row of A1, it will give me answer as 1. Row of A5 will give me answer as 5. So what we would do is we'll say, 50,000 plus row of A1 to A10. A1 to A10 will give me answer as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Because sequence function didn't exist. But in the older version, by the way, if you try this, you will still get a value error. You'll still get a value error, but don't worry. Let's understand the mathematics and we know how to, I'll tell you how to overcome that problem. So row of A1, n minus 1, right? So this should be this minus 1. So this bunch of data gives me my volume. And I want to multiply all these volumes with the price. Prices of the firm A, which is 20 into 1 plus 5% AR power n minus 1. Sequence of 10 minus 1. Right? A into R power n minus 1. So these are my prices. So in the older version again, if I was multiplying this with, so this is my volume, you will still get a value error, but I'll tell you how to get the final answer. Times 20 times 1 plus 5%, because multiplied by price, and price follows this geometric progression. Raised to the power n minus 1. How do we get n? Row of A1 to A10 minus 1. Right? Now, when you're getting this value error, why older version will give you value error is because there are 10 values here. It didn't have the capability to put 10 values in 10 different cells. That is there only in Office 365 and Zoho and Office Online. Our idea is we just want one answer, right? We don't want all 10. We want to add up all of them and want it as one answer. So what you can do is just put that under sum product. A sum product function could handle this array very well. And I'll divide it by million. Same here. In the new version, I could even use a sum function actually. I don't even need a sum product. In the older version, you would have needed sum product divided by 10 to the power 6. So I didn't need any of these cells. I directly jumped into it, right? So a very large calculation is something that we could crunch it in one single cell. If we could start, again, going back to it, start thinking in terms of series. Now, there is a bit of Excel involved here, no doubt. But what made us bring down is our ability to look at this as an arithmetic progression and look at this as a geometric progression, right? Earlier, we talked about the mod series, how it works. Mod goes in cycles. Quotient gives us a blocks. Minus 1, how it behaves. These are very fundamental things which would have learnt in, at max 10th standard, tops, right? And these fundamental blocks is what is helping us do it with a little bit of Excel. Just one last thing here. Let's look at this one. Let's say I have various dates and I want to get quarter ending date. How would we do it? Because if it's month ending date, you could use EO month. If I wanted to get the month ending date, I could use a EO month. That'll give me the month ending dates. So for example, if I have to use the EO month function, how many months should I add to get 31st March? 2 months in this case, right? So let me just put it here. So here I have to add 2 months. For February, if it was February, how many months I should add? February is already there, so I should go for the next month, March. If it is March, how many months I should add? Right, I should add 0. And in this case, in fact, life could be much simpler actually. For April, how many months I should add? 2 months again, because it is June. And for August, 1 month, because September is the next month. So how do we identify this? See, if it was only January, February, March, then I can simply do one thing. I can say 3 minus month of January, right? 3 minus month of January automatically comes. But the problem is that won't work for April and August. So what do we do? For April, it is the first month of the quarter, right? And August is the second month of the quarter. So how do we identify which month of the quarter it is? I could use mod function. Let me get the month in a separate line. So 8th month will be mod of 8, 3. Because why again 3?
Quarter. You want quarter ending date.
Quarter, right? So that is why. So you get 2. For April, I should add 1. That we've got. Sorry, we were supposed to do 3 minus mod of this, right? So I could just use this formula. But when I do 3 minus mod, here is the problem. 3 minus mod gives me answer as 3, because mod of 3 by 3 is 0. Right? This should not have been 3. This should have been 0. Because if it had come 3, then it would have been 3 minus 3, 0. We did a very similar thing earlier. We said, take the mod of the previous number and add 1 to it. Right? If you take the mod of the previous number and add 1 to it, then you would notice that this 1, 2, 3, 1, 2, 3 comes. And what I can do is in here, 3 minus the mod, my bad. 3 minus the mod, I could have used it.